when you are dealing with classes, you can add a new variant to a class and extend it from a program that doesn't even know the original source code where the class was defined. Coming from object-oriented programming, you might think of ADTs as a combination of enums and classes. However, there is more. The first difference is that ADT values are immutable. Objects in object-oriented languages tend to be stateful. That means that you can change their internal state. However, ADT values don't have an internal state, and you cannot mutate its state or the value itself. If you want to change it, what you need to do is to recreate it and change the values that you wanted changed while recreating the object. This operation is so common that Scala comes with a way to make this in an efficient manner. Let me show you how to change immutable objects. In fact, we do not change them. What we do is we recreate the object with the fields that we wanted changed. Let's start doing that with our concrete product class. So Scala provides a syntax to do that in an easy way. Instead of recreating the object completely, we can do just a copy. For example, let's create here some product P1 that is a concrete product with code 1 and description my product, and the price is USD 5 and unit 5. We of course need to import price star and quantity star. Now we save, and now let's say that we want to change the code. Now let's say that we want to change this. To change this, we do a copy, and now we have the possibility to change the code to 2, and that will give us a new object. As you see here, the new object has product 2, but it's not this. The old object is a completely new object. And the good thing here is that you can do several at the same time. So val p3 would be something like p1, p2, copy. Then you can say code equals 4, 3, and then we can change also the price. And now it will be in euro, and it will be like 4. And we save, and it doesn't find the euro because we need to write euro, but it's exactly the same thing. We just can modify it however we want, and we will create at each time a new object. That's the way that ADTs do mutation. The second difference is that one can extend classes via inheritance. Although ADTs look a lot like classes in Scala, and they even use the extends keyword, they are not the same. For example, in Scala, to add a new variant to an ADT, you need to add it in the same file as the ADT was originally defined. However, when you are dealing with classes, you can add a new variant to a class and extend it from a program that doesn't even know the original source code where the class was defined. This finality of ADTs is because the compiler needs to check and know all the possible variants at compile time. This helps it to check that ADTs are always valid, and it also knows all the possible cases that it might encounter. The third difference is that in ADTs, all fields are public. This is because ADTs are used to define a structure, not to hide some state. This is important because all functions that consume an ADT or a value defined with an ADT, expect it to be known completely. The fourth difference is methods. You might have noticed that we have not defined methods and just defined the ADTs. To define functions on ADTs, we just define normal functions. Since everything is known at compile time, you can define functions and the user does not need to change the code of the ADT to add new functionality. You just define a new function and you are ready to go. Now let me show you how methods work in ADTs. Let's consider this function, this ADT here for a list. We can define, for example, a method length. And we will have length that returns an integer, and we'll do this match. And if we have the empty, then we return 0. Otherwise, if we have a constructor of something with a tail, we return 1 plus the tail dot length. Now let's save it to check it. Cons is not. Now we have our length method, and in ADTs, methods are just a way to add convenience to the syntax, so that we can write this like tail.length. But you can write exactly the same function here. Just copy paste it, and let's move it a bit to the left. And it would take a parameter here, L, of type mylist. A, we need to import mylist to have the empty and cons, and we have L, and we have the length of L, and this tells me that I need a type parameter for this method. And now we have the same method here as there, and the way that this is normally done for ADT is this one, the one with the parameters. But we get this nice syntax. The final difference is that ADTs support pattern matching. Pattern matching is a feature that allows to decompose an ADT value in its constituents. In Scala, we use the match keyword to perform it. We have already seen pattern matching throughout this course. We have seen it, for example, when writing the length function here. We see this construction. This match is a pattern matching expression, and what it does is that it checks if the value is of one of the variants here is either empty or either cons. But it does more than that. We can, for example, see here that it matches the tail, and it will unify like whatever is in here with this variable, and you can use it on the right side. So here, this is the value that was captured by the pattern matching and is being used here. You can also match more than just the variants. You can, for example, match a more complex structure here. For example, let's say that we want to check if a list is longer than 2. We could define a function longer than 2 that returns a boolean, and we will match this using case cons and whatever after, and it will return true, or else whatever we give it, it will return false. And we save, and we see that we have now this function that matches on the structure of the term, and this is the superpower that pattern matching gives us. You can match on the structure, you can go inside of the structure and recover one of the values, and you have, of of course, default values here to decide what to do when you don't find what you are looking for. That is what pattern matching does for us. That's all I have for today. Thanks a lot for watching this video. If you arrived at this point, please subscribe to my mailing list where you can learn each time I publish a video or a blog post using the link in the description. You can also subscribe to this YouTube channel by clicking on the subscribe button below. And thanks a lot for watching and see you soon.